Yeah, hello, dear students. Welcome to the online class. Many students requested me to discuss about the reagents that are used in organic synthesis. If you are perfect with these reagents, we are damn sure that we are going to do organic questions perfectly. So in this context, I am going to discuss about few reagents. Today we will be discussing about oxidizing agents. Before going into the details, we can get more information or you can get the contact details of me if you scan this. So you will be getting my mobile number and name, of course it is there. You can feel free to contact me at any time for clarification of any doubt with respect to subject. So let us go for the reagents in organic synthesis. Okay, reagents. What are reagents? Reagents are nothing but the used for chemical substance used for oxidation, oxidation or reduction. In your earlier levels or in your earlier classes, you have learned about oxidation and reduction. Okay, what is oxidation? Okay, what is oxidation? It is nothing but addition of oxygen, removal of hydrogen, increase in oxidation number or loss of electrons. Is nothing but what? Oxidation. Now, if you go for reduction, what is reduction? Reduction is quite opposite to this process. That is nothing but removal of oxygen, addition of hydrogen, decrease in oxidation number or state, or gain of electrons. Nothing but what? Reduction process. So whenever we are discussing about the organic chemical change, we are only considering with respect to oxygens and hydrogen. Now let us try to understand what is that. Oxidation. When you go for oxidation, it's nothing but removal of hydrogen or addition of oxygen. It's nothing but oxidation. So in order to have a better understanding, we have taken three examples. In general, we are not mentioning any reagent, but in order to have a clear-cut idea. If you take ethane, if you are removing hydrogen, we are going to get the compound as ethene. That's nothing but oxidation. Similarly, if you further proceed for removal of hydrogen, we are going to get the ethyne. In the second example, we are not removing any hydrogen here, but instead of that, we are adding oxygen to this. That's nothing but addition of oxygen. Okay. In the third example, here what we are doing, breaking of this bond and adding the oxygen to this. Therefore, we are going to get the oxidized products. But what is the reagent we are using? O3. O3 is nothing but ozone. In the previous example, we have MCPBA. MCPBA is nothing but metachloro for benzoic acid. I am drawing the structure of the compound. Okay, don't worry about the structures. Okay. Meanwhile, just I have an idea about the reagents. Okay, this is nothing but metachloro for benzoic acid. Now, let us go for the reduction. I hope oxidation is clear to you. Okay, let us go for the reduction. What is reduction? Reduction is nothing but the removal of oxygen atoms, addition of hydrogen atoms in an organic chemical change. Now we have taken acetone. Here we have taken acetone, or it is also known as propanone. We are removing this oxygen and adding what? Hydrogen to this. This is nothing but what? Reduction. What is the reagent which we are using? Zinc amalgam HCl. Zinc amalgam HCl. This what are the reaction you are doing? Is nothing but Clemmensen reduction. Clemmensen's reduction. Clemmensen's reduction. This process. So just remember the reduction process now. Don't worry about all this. Just for your information, extra information I'm giving here. Now let us go for the second example. What we are doing, adding hydrogen. Here one hydrogen, here one more hydrogen, which is resulting in the formation of ethane. This is nothing but catalytic hydrogenation. Catalytic hydrogenation. Now, let us try to understand in detail. So the reagents which are used for oxidation are known as oxidizing agents. Reagents which are used for reduction are known as reducing agents. If you want to say in one simple line, oxidizing agents are the agents which oxidize the other and internally gets reduced. That process is called oxidation. Similarly, reducing agents are the agents which reduce the other and internally gets oxidized, are nothing but what? Reducing agents. Now, in our today's class, we'll try to discuss about the different reagents. Specifically, is nothing but oxidizing agents. Now, if you observe carefully this one, okay, if you observe carefully, approximately students we are having a 22 reagents, 22 reagents. Don't get panicked by seeing all these things. So we'll try to make it as simple as so you don't think that our brain is overloaded. So we try to simplify that. We try to simplify that by having a simple method how to do that. Okay. So if you are having proper systematic plan, then you will feel that we are very much happy with this field. Now let us try to understand. So total we have 22 approximately we are, which are important we wrote. Okay. First one is the potassium permanganate. This is manganese dioxide. Next, chromium reagents. We have potassium dichromate plus H2SO4, that is nothing but acidified potassium dichromate. Next one is chromium trioxide. Chromium trioxide in combination with H2SO4 and acetone is known as Jones reagent. If you are taking only pyridine or pyridine, I'll write the structure of this pyridine here. It is same as benzene only, but we have nitrogen in between, one nitrogen in between. Okay, this is nothing but pyridine, organic base. Is known as Sarat's reagent. Along with pyridine, if you take CH to Cl2, then it is said to be as Collin's reagent. Apart from this, we have here one more thing is PCC, pyridinium chlorochromate, which can be obtained by this method, which is readily available also commercial. Next, H2O2 is hydrogen peroxide. For acids, we have already came across this MCPB in the earlier slide. Dimethyl sulfoxide, ozone, selenium dioxide, osmium tetroxide. What is the specialty of this osmium is osmium is having highest oxidation number in the periodic table, that is in the form of osmium tetroxide. Okay. Next is we are having silver salt of carboxylate with iodine. We have to Prevost and Goodwood. Don't worry about those names now. Just have a brief idea about the reagents. NBS. NBS is nothing but N-bromo succinamide. Okay, N-bromo succinamide. Next is lead tetraacetate, silver carbonate, periodic acid, aluminum isopropoxide, DDQ, dichloro dicyano benzoquinone. That is nothing but DD. This will give last priority in our explanation. Okay. Next is a tolerance reagent. Generally, we are coming across these reagents in CBSE board exams as well as in practical Viva exams or practical exams. We have to see. Next, Fellings reagents is the same. Okay, in practical exams or CBSE. Based on this, we are having few questions in state-wise exams. Now, let us try to discuss in detail, but in a systematic manner. Okay, how to understand this? Okay, now chalo bachcho, now we'll try to discuss them in a proper systematic manner. Now I'm going for first. Now first, don't worry. Okay, now let us try to understand what it is. Primary alcohol or secondary alcohol can be converted into corresponding aldehyde or corresponding ketone. Here we have one more one. Ketone. Okay. Alcohols are converted into carbonyl compounds. But how? Big question. How? Okay. So we have to use specific reagents. If you are perfect with these reagents, whatever may be the question, in which format may be the question, you can do it very easily. So I request all students to concentrate properly in order to have a better understanding. Okay, this is the first one. What are the reagents? Now let us see the reagents one by one. Okay. Now, what is the first one? Chromium trioxide. Chromium trioxide in combination with acetone plus sulfuric acid is nothing but Jones reagent. Chromium trioxide pyridine. Chromium trioxide pyridine plus DCM. They are nothing but what? Chromium reagents only. This is also chromium reagent which is obtained from here. Okay, pyridinium chlorochromium. Next, copper at 5 heat. Instead of heat in exam, they may give like 573 Kelvin. N-bromosuccinamide, DMSO is nothing but dimethyl sulfoxide. I am writing the structure, but so please make a note of this structure also. Dimethyl sulfoxide. Next is opener oxidation. That is aluminum isopropoxide. How many are there? Three are there. So we'll write the compound structure like this. Here I am writing bond like this. Isopropyl oxide. Okay, oxygen. This is the aluminum isopropoxide. Okay, oxidation. Up to here. So now, up to here means total 9 reagents. Yes, 9 reagents are very much suitable in converting the primary alcohol I am writing here on the right hand side into corresponding aldehyde. If you are taking secondary alcohol like this, that is converted into corresponding ketone. All 9 reagents can be used for this purpose. So what you have to do? Don't worry about the that 22 number or 26 number of that reagents. Just check these reagents properly. Out of 11, 9 are used directly here. Okay, 9 are used directly in converting the primary alcohols to aldehyde, secondary alcohols to ketone. Now you may have some doubt. What is this NBS? Okay, I'll write here. What is that NBS? NBS is N-bromo. N-bromo succinamide. So how to write that? I am writing here compound structure. This is C double bond O like this N here here. This is nothing but N-bromo succinamide, which is used for converting primary secondary alcohols to corresponding carbonyl compounds. So, bachcho, almost all reagents are directly used. Now, I'll give extra information for you. Now, let us go for the next slide. Of course, we'll cover sodium carbonate and MnO2 in the next slide by taking simple examples. Okay, let me discuss about the example. Let me explain you all clearly by taking simple examples first. Let me take this CH3, CH2, OH. On reaction with particular reagent, we are going to see the formation of this compound. What are those reagents? Directly use 9 reagents which are there. Okay. You may use NBS or DMSO or PCC or chromium dioxide with combination of sulfuric acid or acetone like that. All 9 reagents you can use directly. Now what I am doing, I am taking one more compound like this. OH here, here CH. Propan 2 or use 9 reagents. So directly we are going to see the formation of ketone here. Up to here CBSE level, normal board level example. So in your competitive exams, they may give in the structures like this. Okay, confuse करने के लिए दे subject. Okay, what is it like this? Okay, they may give like this. Okay, they will ask, they will ask to convert into corresponding compound. Okay, double bond over here. Yeah, like it's same. Remaining everything is same. So what you have to do, you can use any one of the reagents. So we are going to see the conversion of the secondary alcohol to corresponding ketone. Ketone. Now here we'll take one more example, dear students. Like I take it DMSO example. If you are using R COH, here H, here R, in the presence of DMSO. If DMSO is used in the combination of oxalide, oxalide, oxalide chloride, okay, oxalide chloride and tertiary amine means they are acting as a supporting co-catalyst. Okay, now we are going to see the formation of the ketone. Whenever you are using, whenever you are using DMSO in combination with this oxalide and tertiary amine, that is said as Swern oxidation. समझ में आ रहा बच्चों? That is nothing but what? Swern oxidation. Okay, now I'll go back to the previous slide once. So, what are the reagents which are left? Now, here 10 to 1. Okay, we have so much of matter on the screen. I will erase all the drawings. Okay, we are having silver carbonate and manganese dioxide. What is the specialty of this silver carbonate? Okay, let me explain it very clearly. Silver carbonate can reduce, sorry, can oxidize primary and secondary alcohols into corresponding carbonyl compounds. Okay, here Ag2CO2. If you have only one group like this, CH3 CH2OH here, then it is converted into CH3 CHO. But instead of that, if you are having like this, OH here, okay, I am taking compound like this where we see both primary and secondary. This is primary alcohol, this is secondary alcohol. Whenever you have combination like this, silver carbonate Ag2 CO2. Silver carbonate will specifically oxidize only secondary alcohol. Okay, this was the position where secondary alcohol was there. That is converted into corresponding carbonyl group. Now let me take the example for MnO2. MnO2 is nothing but manganese dioxide. Generally, it is preferred for allylic and benzylic benzylic groups, benzylic alcohol. So, how to have a clear-cut picture? We'll take one example. This is allylic. Allylic means I tell you, Bacho, if you are unable to understand the allylic, just write down the alphabet A in capital A. One, two, three lines. So accordingly, three carbons. One, two, three carbons. That whenever you are having three carbons with one double bond, is nothing but what? Allylic. On reaction with what? MnO2, It is converted into it is converted into aldehyde. Okay. Now, in a similar fashion, if you have benzyl alcohol or benzyl alcohol like this OH, it is also converted into corresponding corresponding aldehyde. समझ में आ रहा है बच्चा? I hope you are enjoying the class. Please, if you are having any doubt, as I told you earlier, that please scan that QR code and send me your doubts through that WhatsApp. Okay. Now, uh, almost we have covered all the reagents from the first slide. That is this one, converting alcohols to carbonyl compounds. What we have done so far, just I want to have a small recap. So we have used chromium reagents, all chromium reagents we have used. That's why I mentioned nine. Nine includes up to here. Okay. We are using copper at 573 Kelvin. Next, NBS, DMSO, all those. And we have discussed the silver carbonate specifically and manganese dioxide. Here, one point you should know. Always we are stressing on primary and secondary alcohol. If suppose, if you are having, if you are having tertiary alcohol like this, tertiary alcohol, then if we are going to use copper at 573 Kelvin, then we are going to see alkene formation. We are going to see the alkene formation. What we are seeing exactly? The removal of one hydrogen from here and OH group here. Therefore, plus H2. That is nothing but converting tertiary alcohols into alkenes. Okay, someone may have also? Yes, thank you. And we'll try to go for discuss the next exam. Next, first case we have done. What is the first one? We have done alcohols to carbonyl. Now we'll go to the second one. From here onwards, it will be very easy for you. Now you got some idea. Okay. The second one, what we are doing, alcohols to corresponding alcohols to corresponding carboxylic acids. How we are doing that one? By using simple reagents. Okay. Let us take few examples under this category. Here, first what we are doing, potassium permanganate plus H2SO4. Here we have shown in the ionic form, we are writing in full. Okay. Next is potassium dichromate K2Cr2O7 plus H2SO4 gives what? Chromic acid. Okay, next is dilute HNO3. Now let us try to understand this conversion. So how we are going to do it? I will write CH3 here, CH2 OH. I am taking simplest compound for your better understanding. Okay, on reaction with KMNO4 MnO4 slash in the presence of H plus results in the formation of CH3 COOH, acidic acid, ethanol to acetic acid. Instead of potassium permanganate, instead of potassium permanganate, we can also use K2Cr2O7 in the acid medium. Otherwise, we can also use dilute dilute HNO3 nitric acid. This will convert primary alcohols primary alcohols to corresponding carboxylic acid. Sir, students, you may ask one doubt also. Sir, is it applicable for this kind of compound only? Is it not applicable to benzyl? Yes, it is applicable to benzyl alcohol also, CH2. Oh, this is nothing but benzyl alcohol. On reaction with all these three reagents, results in the formation of benzoic acid directly. So this is one of the method where we are going to convert this benzyl alcohol into corresponding carboxylic acids. I hope you are understanding, dear students. Okay. Now I'm going to the third one. What is the third one? Here we are going to convert alkene. We are going to convert alkene. Okay. Alkene to corresponding epoxide. How we are going to convert? We have only limited reagents under this category. Okay. Before going into that, just I want to have a small question. In the first thing, that is conversion of alcohol to carbonyl, approximately we have we have 11 or 12 reagents. Okay, here 11 reagents we have seen. But when you are going for the second one, how many reagents are there? Only three. Now, if you go for third one, you can see the limited number of reagents. What they are? Let us try to understand by taking simple example. Okay. Now what I am doing, alkene I am taking. Okay. Alkene it may be cyclic form or open. I am doing with cyclic. I am using MCPBA. Already I wrote the structure of MCPBA in the first slide. Otherwise I try to write once again. Okay. This is benzene where we are writing C double bond O OF OF H. Here I am writing CF. Metafluoro. Why? Because this is ortho, this is meta, this is para. Okay. Metafluoro for benzo. Why we are telling it as per? Because peroxy linkage is there. Metafluoro for benzoic acid. Here we are seeing here we are seeing the epoxide formation. We are seeing the epoxide formation like this. Over here, this center. You are seeing these above the plane lines. This is nothing but sin epoxide. Sin epoxide. Okay. Similarly, we are going to get the epoxides. What are epoxides? We will write in general form. C double bond C like this. On reaction with per acids or H2O2 or silver in presence of oxygen, we are going to see the compound like this. These are nothing but what? Epoxides. समझ में आ रहा बच्चों? These are nothing but epoxides. These are playing an important role in the opening of the epoxide roles where we are going to get 1 comma 2 diols. We'll try to discuss those things in the next. Yeah. Up to here, is it clear? Yes. Now let us go for the fourth one. What is the fourth one? We are taking alkene. We are taking alkene and converting into 1 comma 2 dihydroxy compounds. Converting them into 1 comma 2 dihydroxy compounds. How we are going to convert into 1 comma 2 dihydroxy compounds? Let us try to check that here. Okay, we'll go to the next slide. 1 comma 2 dihydroxy compounds are set up as what amount? Diols. Okay. Now we have total 5 reagents. Here, total we have 5 reagents. Let us try to understand. The first one, what is the first one, Amma? This is alkaline KMnO4. Next one is osmium tetroxide. Yes, this is also capital here. Osmium tetroxide. Next one is silver salt of carboxylate. Yes, here also same, but the difference is this one. Aqueous acetic acid. Here aqueous NaOH means acidic medium here. Here this is basic medium. I'll tell in detail. Okay, by taking one. Next is MCPB. Already we have learned about MCPB. Now we'll try to understand by taking example. Okay. Okay. Now what we'll do, we'll try to understand by taking example. I am taking an alkane, cyclic only I am taking. Okay, cyclic I am taking, and I am writing like this. Okay, I am writing like this. My writing is not that good on this digital pad. It will take some time for me to get familiarize with this. Alkaline KMnO4. KMnO4. Here what is happening? Here we are going to see the formation of diols. So how they are formed? I am writing above the plane line here. Here also above the plane OH. Same side. We are having same side. That's why if you see observe carefully, these OH are on the same side. That's why it is said to be as same. Okay. Next, let us go for the second reagent. Osmium hydroxide in combination with sodium sulfide. We are going to see the formation of same compound like this. Okay. Above the plane here OH. Here also we are going to see the above the plane. Here what we are seeing, this OH are on the same side. Therefore, this set to be as syn addition, syn hydroxylation. Now let us go for the third one. Okay, third one. Here I use big arrow here. R COOAG, silver salt or carboxylate in combination with iodine I am taking in the presence of what? Acetic acid. Aqueous acetic acid. Why we are using this acetic acid? Because for hydrolysis purpose. Hydrolysis purpose. Here what is happening? When you are using this combination, that is said as Woodward modification. I am writing compound. Here also we are going to see the formation of the compound like silicone. This is said as Woodward, generally again JE advanced modification. Okay, syn hydroxylation. Last, not last exactly, but small modification in the above reagent. That is RCOOAG plus iodine in the presence of aqueous NaOH base hydrolysis. In the above case, we have done acid hydrolysis. Now we are doing base hydrolysis. So here we are going to see the formation of compound, that is formation of diols in the opposite. That is nothing but anti opposite. One is above the plane and another one is below the plane. Similarly, we are going to get the same product by using MCPBA. Sorry, MCPBA. Sir, you told that it will form epoxide, but you are saying one comma. Yes. Let us try to understand. I am taking this cyclohexane plus MCPBA. MCPBA will result in the formation of epoxide. Here up to here, it is very clear. Epoxide, as I told you previously, that it is above clear. Now, when you use base, I will try to write here due to lack of space. I am trying to write like this. OH will attack from the below the plane, therefore one is above and I am writing a broken line OH. Here I am writing OH. Tick. Call it. This is nothing but anti. That's how we are going to learn anti-hydroxylation. So when you are seeing this video, please try to pause wherever it is necessary and try to understand it very carefully. As I mentioned you that if you have any doubt, please let me know through that WhatsApp. Okay. Now fifth one. Let us go for the fifth one. What is the fifth one? In the fifth category, we have many things to discuss. Okay. One is carbonyl compound. Another one is acid. Another one is the oxidative cleavage, so which forms CO2. Okay. Now let us try to discuss them in detail. Okay. Here, Bacho, you are seeing some matter on the right hand side. Try to pause the video when you understand this concept. To completion of this, to try to check this matter which is on the right hand side. Now let us try to understand. Here they gave ozonolysis. First of all, we will try to have a clear cut picture. What we are doing, we are taking alkane, converting into carbonyl. Up to here only we are discussing now. Let us try to take an example. Okay, what is that example? R C here R dash double bond C. Here I am writing H. Here I am writing R2. R1 R2. We are taking that. Here I am treating this with ozone in the presence of zinc plus H2O2 and H2O. That is nothing but reductive ozonolysis. Actually, ozonolysis have been divided into two: reductive ozonolysis and oxidative ozonolysis. Okay. Here we are discussing only reductive ozonolysis. Here, just simply what you do, wherever the double bond is there, try to break that and add oxygen here and one more oxygen on this carbon. So therefore, we are going to get the compound like this: R C R1 double bond O plus C H here double bond O here R2 here. Okay. Here we are going to see the formation of ketone, and here we are going to see the formation of alkene. It all depends on the reactant which we are taking. If the reactant is having substituents like this one, then we are going to see the ketone form. If the reactant is having like this H, then we are going to see the formation of alkene. If suppose, we are taking compound like this CH2 CH double bond like this. Okay, sorry, I will erase this uh, two here. Okay, now I think this. Okay, now we are taking this. What is that meaning? This is nothing but terminal. Terminal, matlab end. Terminal alkene. In terminal alkenes, what you do, just break this and add O here, add O here. We are not writing the ozonide intermediate directly. We are writing for CHO here plus H C double bond O H. This is nothing but formaldehyde. This is nothing but what? Formaldehyde. Okay. Similarly, we can use the other reagents also. What are the other reagents which we are using? So NaIO4, okay, as with combination with potassium permanganate. Okay, here we are going to see the bond breaking. I try to take one specific example. R here OH I am taking H here one more carbon with OH here. If we are reacting with this with NaIO4 sodium periodate, then we are going to get the compound like this CHO here plus RCH. What is happening exactly here? Just simple breaking this bond and oxidizing this into corresponding aldehydes. This is the way we are going to convert. Okay, we'll go to the next point. Next. These are like miscellaneous. Selenium dioxide. Okay. Selenium dioxide. Here, selenium dioxide is used for oxidizing alpha CH. Alpha CH to the corresponding carbonyl compound. Alpha CH to the corresponding carbonyl compound. Where is that alpha? Now, when you are taking this compound, example, carbonyl compound, this is a carbonyl. I am writing here carbonyl, carbonyl. Side by this carbon is nothing but alpha carbon. Okay, these are oxidized with selenium dioxide in the presence of actually water and acetic acid. Okay, there we are going to get selenous acid. They will not ask all those things, but in the presence of selenium dioxide, we are going to see the conversion of this active carbon, which is having hydrogens, okay, converted into new carbonyl. New carbon. Better if you take one example and try to apply this concept. Now we will take this one, C double bond O, C H. What is this better? This is nothing but acetophenone. Acetophenone we are taking. React this with selenium dioxide. Then what we are going to see? Yes, few students are answering. C double bond O here, C double bond O here. This is nothing but two carbonyl groups present side by side. In your exam, in your competitive exams, how they are going to ask? They will ask that they will give benzene on reaction with particular A gives B, which on reaction with C we are going to get this compound. Then you should be able to identify what is that A, B. They'll give hint like only this part. So by seeing this, you should get whenever you are eyeing two carbonyl side by side, you should get an idea about selenium. Whenever you are having something about selenium dioxide, obviously you will be having this. Okay. Practice करने के बाद you will feel very easy. Okay. This is your first time. If you are listening for first time, you feel that it is tough. If you repeat this video once again, then you will feel comfortable. Okay. Next, let us go for the second one. Means not second one. In miscellaneous, we are discussing lead tetraacetate. What we are doing? Cleavage of 1 comma 2 diols. What is the cleavage? It is said to be as oxidative cleavage into 1 comma 2 diols into carbonyl compounds. So, in competitive exams, generally they may not ask in this simple format. They generally prefer cyclic compounds. Cyclic compounds. So, if they are asking giving like this LTA, lead tetraacetate for timing you assume that this is a lead tetraacetate. So how many carbons are there here? One, two, three, four, five, six. So what you do, just first write down like this: C double bond O here, H1 here, 2, 3, 4, 5, 6. My writing is very bad on this digital pad. Okay, this is the what is the name of this compound? Anyone try to give the name of this compound. Here, I'll write one mnemonic for my such good. I'm writing here everyone. Apples. Apples. O stands for oxalic acid. M stands for malonic acid. S stands for succinic acid. G stands for glutaric acid. A stands for adipic acid. सर ये पूरा क्यों बोल रहे हैं? Now let us try to understand this. Why we are discussing about this pneumonia. Oxalic acid I am writing here COOH bond COOH. Here we are in two carboxylic acid. Now let us try to uh, have CH2 in between these two. So this is nothing but what? Malonic acid. If you are increasing on CH2, it is nothing but malonic acid. If you increase one more CH2 in between, CH2, here CH2, CO. This is nothing but succinic acid. In similar fashion, if you increase one more, it is nothing but glutaric. If you are increasing one more, it is nothing but adipic acid. So in glutaric will be in succinic we are having 1, 2, 3, 4. In glutaric we will be having 5 carbons. In adipic acid we will be having 6. We can check here 1, 2, 3, 4, 5, 6. 6 means adipic. Like simple method to remember. Okay, adipic acid. Okay, I am clearing all the drawings. Now let us go for the next slide. Next slide is DDQ. DDQ is nothing but 2 comma 3 dichloro 5 comma 6 dicyano. There is okay now. There is no need for you to learn the structure, but for your information purpose, I am giving this. Okay, now we want to go here. Sorry, got okay. Now I will erase it. clear on my highlight once again. Here, but, okay, I'll check something. So now what I here we will try to write this structure like this. Double bond O here Cl, here Cl, here Cl, here this is nothing but the structure of the bleeding. What exactly? This is only taking place in allylic and benzene. This is a benzene ring. Everyone knows. Side by carbon. This and this are nothing but benzyl. When from here it is removing hydrogen. That's why it is set up as a dehydrogenating agent. So whenever you are removing here, we are getting positive charge that is generally balanced by this hydrogen. That's why we are getting double bond here. In a similar way, we are going to see the formation of it. This is the importance of this DDQ. They will give tetraline like this. They may ask what is that reagent, or if you are using this reagent, what will happen? This is advanced level only. Next, tolerance test. Tolerance test here. Ammoniacal silver nitrate is used for converting aldehyde into corresponding carboxylic. What is it? This is nothing but ammoniacal silver nitrate. How we are now after having the reaction, we are going to see the formation of diamine silver hydroxide. This is acting as oxidizing agent. Oxidizing agent which is converting aldehydes, not ketones, to not applicable for ketones, only for aldehydes, converting aldehydes into the corresponding carboxylic acids. Okay, corresponding carboxylic acids, where we are going to see the formation of silver. That's why it is set to be as our silver mirror test also. Silver mirror, already it is there, but mirror test. Okay, silver mirror test. Next, let us go for the last one of this class is Felling's reagent. Felling's reagent is used is used for converting aldehydes into corresponding carboxylates. What is the Felling's reagent? We cannot have directly, we should have the combination of this A and B. Okay, what is that? A, copper sulfate solution. B is alkaline sodium potassium tartrate. This is nothing but what? Rochely salt. On combination, we are going to get the deep blue color. This indicates the starting point. Okay, and upon reaction with aldehyde, it is converted into the red PPT. It indicates the presence of aldehyde or alpha hydroxy ketones. Alpha hydroxy ketones are nothing but like this CH3, C double bond O, here CH2 OH. These are nothing but alpha hydroxy ketones are converted into corresponding carboxylic acids. Okay, Bacho, I hope I'm very clear. If you are going to replay this once again, the concepts will be very clear to you. Okay, overallly, we have covered 22 oxidizing agents in simple 8 slides. Okay, so what I suggest you all is try to recap those things or explain at least 2 to 3 times. Then it will be very easy for you to understand. So so far, I thank everyone for listening patiently. Thank you, dear students.